TCU controls the shift motor on the gearbox. The park motor has an encoder, output 4-bit code, used to determine park motor position. TCU interface via automotive CAN bus, receive information from other vehicle systems, drive motor speed, vehicle speed, parking request, etc. TCU receives the relevant shift condition and shift request and directly controls the parking motor to drive. The pull to fasten or release the ratchet wheel to park or release the parking function. Connect diagnostic equipment, automotive fault diagnosis device, also known as car decoder. It's an automobile control system that can work with the car's electronic control system. Computer that communicates. Ability to read data streams from automotive electronic control systems. And fault codes. Displayed on a monitor. Mainly composed of diagnostic computer connection cable and diagnostic box, also known as CAN analyzer box composition. Connection cable to the OBD to diagnostic interface on the vehicle. DLD EV450 diagnostic interface. Located on the left side of the steering wheel, under the dashboard. Connecting the cable to the diagnostic box. Diagnostic box will car CAN network information. Convert to computer recognizable information. Pass it on to the diagnostic computer. Diagnostic computer receives information and displays it on the monitor. Attention is required when connecting the diagnostics. Turn off the ignition first. Pass the diagnostic box through the connecting cable. Connects to the vehicle diagnostic interface. Then connect the diagnostic box to the diagnostic computer. Bluetooth can be used. Connecting the diagnostic box to the diagnostic computer. Turn on the ignition when the connection is complete. Read information about the vehicle. Caution is also needed when disconnecting the diagnostic. Turn off the car's ignition first. Disconnect the cable again. To protect the diagnostic box from voltage shocks. Protective diagnostic box. Enter diagnostics after connection is complete. Read relevant data streams. Troubleshooting and diagnosis of reducer controllers. Measurement of auxiliary battery voltage. Connect the red pin to the positive terminal of the auxiliary battery. Connect the black pin to the negative terminal of the auxiliary battery. Read DC voltage values. Measures 11 to 14 volts under normal conditions. Check reducer controller supply capacitor wire EF to 6. Hold the red pin at arm's length. Connect the inputs and outputs of EF26 respectively. Attach the black meter to the metal housing of the bodywork. Read DC voltage values. Measures 11 to 14 volts under normal conditions. Check EFR6 resistance. Place the red and black pins. Connect to the input and output of the EF26, respectively. Read the resistance value. Normally should be less than 1 ohm. Test capacitor wire EF26 line resistance to ground. Connect the red pin to the input of EF26. Attach the black meter to the metal housing of the bodywork. Read the resistance value. Verify that there are no short circuits in the wiring. Normally, it should be measured because infinity. Check reducer controller power supply fuse. FR6 input volt. Connect the red meter ratio to each of the EF26 inputs. Attach the black meter to the metal housing of the bodywork. Read DC voltage values. Measures 11 to 14 volts under normal conditions. Check reducer controller supply capacitor wire EF to 6. Output voltage. Compare the red table. 2. Connect to the outputs of EF26 respectively. Attach the black meter to the metal housing of the bodywork. Read DC voltage values. Measures 11 to 14 volts under normal conditions. Check EF26 plug-in resistor. Compare the red to black table. Connect to the input and output of the EF26, respectively. Read the resistance value infinity. Normally should be less than 1 ohm. Determine the EF26 fuse is blown. If the above tests are normal, then replace the EF26 fuse. Thank you for watching this video. I hope this helps you in your endeavors.